So, welcome to the study of quadratic functions. So, if you recall in the previous lecture, we had started looking at finding the roots of a quadratic equation, and we said that if you look at the quadratic equation a x square plus b x plus c equal to 0, then it has two roots, x is equal to minus b plus minus b square minus 4 a c by 2 a, provided b square minus 4 a c, the quantity has a square root, that means it is bigger than or equal to 0. So, let us look at the case when it is negative. When b square equal to minus 4 a c is less than or equal to 0, this is a real number which is negative, it will not have any square root. So, no real root exists for this quadratic. So, actually roots exist as a complex number, but for our considerations we are looking at only the real roots. So, for a quadratic a x square plus b x plus c equal to 0, if b square minus 4 a c is less than or equal to 0, then no real root. So, this should be strictly less than 0, because only if it is 0 then the root will exist. So, there is a small typo here, b square minus 4 a c is strictly less than 0, no root will exist, because then it is a negative quantity. Right. So, no real root exists, this is okay here, that there is no real root. When it is equal to 0, that means two roots exist, but both are equal. So, this is called identical roots. So, real roots exist, both are identical. So, the roots are equal to minus b divided by 2 a. So, these are the roots of a quadratic. So, for b square minus 4 a c bigger than 0, as we have seen, two distinct roots exist and they are given by these two values, minus b plus square root minus b minus square root divided by that. So, these are two distinct roots. Next, what we want to do is, we want to look at this function f x is equal to a x square plus b x plus c, a not equal to 0. How does one represent it graphically? What is the graph of this function? That means, we want to plot all the values x comma y such that y is equal to a x square plus b x plus c, a not equal to 0. How does one do that? Let us try to analyze this slightly. So, first of all, this is a quadratic. So, let us assume that b square minus 4 a c, okay. At the most it can have two roots, right. So, x 1 x 2 are possibly the roots, it may not have any real root, it may have two distinct real roots, or it may have only one real root, both the roots may coincide. So, all this data can be put as part of our information, namely when is if x is equal to 0, y is equal to c. So, the graph also passes through the point 0 comma c, it cuts the y axis in at the point 0 comma c. So, it cuts the x axis at 2 points, possibly it cuts the y axis at the point 0 comma c. So, these are points of intersections with the axis, two axes. Next, let us look at a slightly simpler situation when in the quadratic the coefficient b and c both are equal to 0. So, in that case the quadratic equation becomes f x is equal to a x square. Okay. So, a simple observation that for the quadratic f x is equal to a x square, what are the roots? A x square equal to 0. So, x is 1 equal to 0, x 2 is equal to 0. So, both the roots coincide and it is 0. So, the curve passes through the origin 0 0, and right, it actually is touching at the point 0 0, because both the roots exist, it cannot go below 0 0. So, for a bigger than 0, when a is bigger than 0, f x is a x square, right, x square is always a non-negative quantity. So, a x square is bigger than 0. So, for every other value at 0 the value is 0, for every other value f of a is bigger than f at 0 for all x. So, what does that indicate? That indicates that f x has the smallest value at 0 and that value is 0. Hence, the graph of the function will always be above the x axis. Every other point which is on the graph of the quadratic y equal to a x square will be above the x axis. So, and the graph will be touching at 0 0, it is always above the x axis, it cuts the y axis, right. C is 0, so that is also gone. Okay. And let us observe one thing, that f x which is a x square is a times minus x square, which is same as f of minus x. So, that means f of x is same as equal to f of minus x. So, this implies that the graph is symmetric around y axis. If you change x to minus x, the value of y remains the same. So, x comma y, if it is on the graph, then minus x comma y is also on the graph of the function. So, that means it is symmetric, right. We are trying to get a picture of the function, a visualization. If x is equal to bigger than 0, right, then f x is increasing, of course, because f x is equal to a x square. So, if x is bigger than 0, then it is increasing, right. Further, note that a x square is always less than a x between 0 and 1, because x square will be much smaller between 0 and 1. So, the graph between 0 and 1 will lie below the line y equal to a x, and it will grow faster, it will be above a x square is bigger than a x. So, it will take over the graph of a x for x bigger than 1. So, when if a is equal to 1, that is equal to y equal to x square, then we can easily plot the graph. So, this is the graph of the function y equal to x square. We have even taken a equal to 1 just to simplify and understand what is the graph, right. So, this is the graph of the function y equal to red 1 is the graph of the function. This is a line y equal to x, because a equal to 1. So, up to the value 1, the graph is below the line, and then it overtakes and grows faster, and it is symmetric around the line y axis. Here one thing would like to mention, that we have very nicely drawn this kind of a smooth kind of a curve for the graph. How do we know this graph actually looks like this, right, or it does not go kind of wavy, kind of it does not go like this, right. So, all these things we will see later when we look at the notion of derivative of a function. So, at present we are just intuitively we can take some values of x between 0 and 1 and join them as we do in school, and see that probably this will look like the graph of the function. This graph is drawn with the help of a software. It is called GeoGebra, GeoGebra, GeoGebra. You can search the internet, and this is a open source software for plotting functions and doing many other things in geometry. So, along with in this course, I would suggest that you download that software and start getting to know how to input a function and get its graph. That will help you to understand the graph, the functions, and many other things better, because visualization of something always helps. Okay. So, this was when a is positive. When a is negative, right, for example, y equal to minus x square, all the values are going to be negative. So, it will become a graph below the x axis. In fact, the graph of y equal to minus a x square is just the reflection of the graph of y equal to a x square when a is positive. So, graph of the quadratic. Okay. For a general quadratic, so we look at the graph of the quadratic when a was 1, say b is 0, c is 0. What happens if b and c are not 0? How do we plot the graph of the function? Well, what we are going to do is, we are going to bring this equation a bit similar to our equation of y equal to x square, and then sort of suggest a graph of the function. So, for that let us observe that a x square plus b x plus c, we want to write it in the form of a multiplied by x minus h whole square plus k. So, we want to transform this equation a x square plus b x plus c as a times this. So, that means, we want to, a is already given to us, b is given to us, c is given to us. We want to find constants h and k, so that for every x these two equations are satisfied. And for that to be true, for example, if x is 0, that says c is okay. If x is 0, from here we can calculate what is c. Okay. C should be equal to b by 2a, and k should be equal to this quantity. So, from here we can calculate, or we can compute the coefficients of the like powers and compute. So, once you have done that, the graph of so using these relations, so let me just repeat that, saying this is equal to a into x minus h square plus k. That means, the coefficient of like powers must be equal. So, k is equal to c. Okay. If you want, what you can do is k is equal to c, x minus h whole square. Okay. You can open it out and then compare. So, because if you want to write this, then the right hand side will be a x square plus x minus h whole square will be x square minus 2 a h plus h square, and when you open out, you will get a times x square minus 2 a x h plus a h square plus k equal to this. So, when you compare, constant term here will be equal to constant term on this side, coefficient of x is b on this side. So, you will get a coefficient of b on that side, and that will be minus 2a, okay, minus 2a, and the coefficient of x is a x square. So, coefficient of x square is equal to a, that is equal to a. So, from those three equations, you will get essentially only two equations, you will get the value of h and k. So, if this equation is to be transformed into this equation, then h is equal to this value and k is equal to this value. So, I strongly suggest that you work out this and see that the values are correct. So, once you have done that, the equation will look like a x minus h square plus k. So, that how does it compare with the equation y is equal to a x square? So, that says that the y coordinate in the earlier one is shifted by k units, and x coordinate is shifted by h units. That means, this is only a shift of origin. The earlier origin 0 0 is shifted to the origin h k in the new equation, and that means it is something similar to a x square plus b, only we have to translate our origin to the value h k. So, intuitively, so translating along x axis by h units and k by k units to along y axis, first along x axis h units, so that will transform into this, and k units along y axis will transform into that equation. So, that gives you essentially one says that the origin has been transformed, origin has been shifted, origin has been translated to the point h k. So, the curve will turn around, the graph will turn around at the point h k. Earlier it was turning at 0 0, depending on a and is positive or negative. It will have a maximum or the value minimum. The maximum value will be k, or the minimum value will be k at the point x is equal to h. So, and the graph will be symmetric around the line x is equal to h. So, these are just observations translated from the equation y equal to x square. So, the graph of the function y is equal to the quadratic a x square plus b x plus c, when transformed into a times x minus h square plus k, where h and k are given by those values as we mentioned earlier, the graph will look like this. Normally, this point is called the vertex of the parabola, and this is called the axis of the parabola, and this is the point where it will cut. So, that is the point 0 comma c. So, this is the equation. So, let us see how these quadratic equations appear and what do they indicate in our study of economic models in economics. So, let us look at an example. The production of a particular product, there is a fixed cost, namely 18 rupees. In producing that, maybe the rental or electricity or such things. So, in producing a particular product, there is a fixed cost, whether something is produced or not, that much amount is spent, and the variable cost rupees 4 per unit, right. And the demand function, price and demand function of the product is P equal to minus 2Q plus 24. So, this is the data given. We would like to know what is the profit function for this. So, how do you calculate the profit? Profit is the amount spent minus the amount earned. So, let us compute that PQ, pi Q, the profit is the amount earned. So, this is the price at which something is being sold, right, and if Q units are sold. So, product P into Q, that gives you the, so that gives you the income. So, this is the income. So, this is the price you are demanding, this is the Q unit sold, that is the income, and what is the amount spent? 18 rupees are spent anyway, that is the fixed cost, plus the variable cost 4 rupees per unit. So, 4Q is the variable cost. So, this is the cost in making a 1 unit, and this is the amount you earn by selling Q units. So, the difference is the profit. So, minus 2Q square plus 20Q minus 18. So, if producing a particular product, 18 is the cost, fixed cost, and there is a variable cost of 4 rupees per unit, and this is the price versus demand equation. Then this is the profit function, which you immediately recognize as a quadratic. So, let us find out when will the company break even. That means pi Q is equal to 0. So, we have to find roots of this quadratic equation. So, to find out that, we put Q square minus 10Q. So, this equation equal to 0. You simplify, Q square minus 10Q plus 9 equal to 0. When you solve B, so Q is equal to minus B, B is minus 10. So, 10 plus minus B square, 10 square is 100 minus 4 AC. So, 9 into 4 into A is 1, so 36. So, that gives you the value equal to 1 or 9. So, there are two possibilities, that Q is equal to 1 or Q is equal to 9. That means what? The company will break even when it is producing only 1 unit, right, or it will break even when it is equal to 9. So, that essentially means what? Let us try to interpret that, what more we can deduce. So, this is a quadratic with A less than minus 0, right. So, it is minus 2. So, A is minus 2. So, A is less than 0. So, graph is pointing downwards. It is a downward parabola with a vertex at the point. We find HK, that gives you the vertex, minus B by 2A. So, that gives you 5, and K is 4AC minus B square by 4A. When you multiply and do the simplification, that comes out 32. So, for H is equal to 5, K is equal to 32, right, that is the vertex of the parabola. And what does the vertex indicate? That indicates that for the value H equal to 5, K will be equal to 32. So, 32 is the maximum value that Q can take, right. So, for X is equal to H is equal to 5, Q is equal to 32. So, when 5 units are being produced, the maximum profit will be earned, and that is equal to 32. So, the graph looks like this. So, it is the graph below the x axis means the profit company is in the negative, then it breaks even at the point 1 0. That means, when 1 unit is being produced, it breaks even and then goes up, okay. And when it produces 5 units, the profit is 32, that is the maximum it can achieve. And then again if it produces more, it will go the profit will go on decreasing, and it will become 0 when it is producing 9 units, and then it will go in the loss. So, this is how you interpret your profit function. Okay. Right. So, we have looked at the linear functions, linear models, we looked at the quadratic models, and now there are some other functions which appear in the study of economics, commerce and management. So, there are some special nonlinear functions. Of course, quadratic function was nonlinear, but there are some more which we will like to introduce now, so that we can make use of them. So, to motivate and introduce those, let us look at what is called the power function. If you recall, what is the power of a number? It is that number multiplied again and again with itself. So, given any positive real number n, a raised to power n can be defined. Okay. Even for a integer, a raised to power n can be defined. So, for a positive, you define a multiplied with itself, a 0 is 0, and you define by next one as multiplying. So, repetitive multiplications you can do. And for a negative number, you define a raised to power n to be 1 over a raised to power minus 1 if a is negative. A raised to power 0 is already defined. So, this is what is called powers when it is an integer. We want to go a step further, but keep in mind the formula that a raised to power n into a raised to power n is equal to a raised to power n plus m. Even for integers, this makes sense. Okay. So, you can give a elementary proof of this, or you can just rewrite and then do it. Okay. So, other cases can be proved similarly for integers. Now, let us next look at a rational number r, and we want to define a raised to power r, where r is say p by q, where p and q are both positive. So, we are looking at positive rationals. Okay. So, one can define it as a raised to power r to be equal to, this is what we want to define. So, what we do is a raised to power 1 over q, q is a positive integer. So, 1 over q need to be defined, and then to the power p. So, this can be defined if we can give a meaning to a raised to power 1 over q, where q is a positive integer. We will not be doing in this course what it is, but using advanced real analysis, one can show, given any positive number a and given a positive number q, you can find a number called a raised to power 1 over q. So, that a raised to power 1 over q raised to power q is equal to 1. So, this is a mathematical fact. Okay. So, this should be a bigger than 0. This is a typo here. For a bigger than 0, q belonging to n, this is defined. So, for rational numbers, one can define a raised to power a rational number, and then using definition you can prove, or let us assume all these facts, but I am just giving you a route how it is not that easy to define the power function. Okay. So, a raised to power r1 r2 is equal to a raised to power r1 plus r2 once a raised to power a rational number has been defined. For any real number x, if you want to define a raised to power x, this can be done using the notion of sequences. Given a real number x, we take any sequence of rational numbers which converges to it. Such sequences exist, that is called the denseness property of rational numbers, and then a raised to power r n is defined. So, we take the limit of that. Again, it needs to be shown mathematically that this limit will always exist, and it will be unique and so on. So, a raised power x can be defined, and one can prove it has nice properties similar to that of the earlier one, rationals. And so, for a bigger than 1, of course, a not equal to 1, a equal to 1, it will be constant function. A raised power x can be defined with the following properties. So, I have just indicated at a root how this can be defined. If you like, you can just take it as a definition that we have a function f x equal to a raised power x with the following properties, that for every x, a raised power x is defined, its domain is all real numbers, range is a set of all positive real numbers, it obeys the law of exponents, a raised power x plus y is a raised power x into a raised power y, and a raised power x whole thing raised to power y is equal to a raised to power x y. If a is bigger than 1, then this function is monotonically increasing or increasing, and if a is between 0 and 1, recall a is bigger than 1, then it is a decreasing function, monotonically decreasing function. F of 0, if a is 0, for a bigger than 1 and a not equal to 1, f of 0 is equal to 1, one can put that as the value. It keeps on increasing for bigger than 1, and when you are coming closer, it becomes 0. So, between a and 1 this becomes. So, this gives us the graph of the two functions. So, these are the graphs of the two functions. So, what we are saying is, when 1 over a is bigger than 1, this is the graph of the function. When a is less than 1, the red is the graph of the function. When a, so this is defined for all values of x, a raised power x is always bigger than 0, right. And you can see one is the reflection of the other, one can easily show that also. So, these are the graphs of the functions. We will be using this properties of this function and its graph later on in our analysis. This function is normally called exponential function with base as a. So, a raised power x when a is bigger than 0 is called exponential function. So, a raised power x is called exponential function. There is a special value of a when a is equal to e. There is a special number called the Euler number. When a is equal to that number, the function is e raised power x. This number e is not easy to describe, it is an irrational number, and one way of describing this is to show that the sequence 1 plus 1 over n divided by whole thing raised to power n converges, and that number is called e. That is one way of defining the number e. So, for this particular value, the function e raised power x is called the exponential function. So, one way of directly defining the exponential function is this, but then one will have to prove those properties, which is not easy. So, this is the exponential function. Let us see what is why one needs exponential function in our analysis. Let us recall, if P0 is an initial amount with r% rate of interest, and the interest is compounded is compound interest, then after t years, t is the number of years for which it is compounded, the amount is given by Pt equal to P0 1 plus r raised to power t. We had seen this earlier, and we got this the geometric expression. So, this was a geometric progression, Pt is a geometric progression, t is the number of years. Supposing the bank or wherever the interest is giving, the interest rate is applied every 6 months. If the interest rate is applied every 6 months, that means we have to break the year into 2 parts. So, r by 2. So, time interval will be 2 units. So, rate of interest will be half. So, Pt will become equal to this, right. That is how we will come if the rate of interest is half yearly. Okay. It is applied every 6 months. What about if it is applied more m times a year? So, inductively one can say that the amount will grow into P 0 into 1 plus r by m raised to power m t. And suppose that number of parts becomes larger and larger. So, and let us say that m becomes large, so larger and larger. One says that m goes to infinity. In that case, we need to look at the limit of this quantity as m goes to infinity. So, that is equal to this, and by our earlier formula 1 plus 1 by m raised to power m limit, if this is justified, if this limit can be taken in, that says that so this becomes P 0 into e raised to power r t. So, it says if the interest rate is given continuously, then the formula should be, if this is to be done, we have to compute what is this limit. Okay. So, limit of this exists and is called the exponential. That is what we have said earlier also, and here is a precise that E is equal to 2.178 dot dot dot. Okay. So, that is a value. So, but the upshot is what is the value of P t on the right hand side. So, if I am allowed to take limit inside, this becomes P t becomes is equal to P t plus P t into 1 plus e raised to power r t. So, that is the upshot. So, that limit, if it is taken as this, that means this limit one can define e raised to power r that way, and it says, so it behaves like an exponent. So, the growth, the exponential function a raised to power x that we have said, okay, is a what is called a growth function, and this is called when it a is less than 1, this is called the decay function. So, I think what we will do is we will stop here and we will look at the exponential and the growth function in detail in the next lecture. Thank you.